Welcome to the first of two videos on parallel and perpendicular lines. The goals of this video are to define parallel and perpendicular lines and also to determine if two lines are parallel or perpendicular from their equations. Parallel lines are two lines that never intersect. So let's start by taking a look at two lines graphed together on the coordinate plane. If we take a look at this red line and blue line, they are obviously not parallel because they intersect. So what we're going to do here is change the slope of the blue line until it's parallel with the red line. And before we do that, notice that the slope of the red line is positive because it moves up from left to right. So in order for the blue line to be parallel, it must also be slanted in the same direction, so it must also have a positive slope. So as we increase the slope of the blue line, the slope of the blue line will approach the slope of the red line. So right here, the slope of the red line is equal to 2, and the slope of the blue line is equal to 2. So if the slopes are the same, the two lines will be parallel except for one case. Notice if we change the y-intercept of the blue line, it continues to be parallel to the red line except in one case. If the y-intercepts happen to be the same and the slopes are the same, of course that would be the same line, which has an infinite number of intersection points. So this leads us to the conditions that must be met in order to have parallel lines. The slopes must equal each other, but the y-intercepts must be different. So again, two lines are parallel if they have the same slope and different y-intercepts. Another way to indicate this, if the lines are in slope-to-intercept form, is that m1, the slope of line 1, must equal the slope of line 2, but the two y-intercepts, b sub 1 and b sub 2, must be different. Let's take a look at this one more time. Here we have two different lines. Let's just determine the slope of each of them. Looking at the blue line, if we pick two convenient points, let's say this point here and this point here, we can see the slope would be up 1, right 2. So the slope of the blue line is equal to 1/2. And the slope of the red line, if we go up 1 and right 2, is also equal to 1/2. And notice that the y-intercept of the blue line is equal to positive 3, and the y-intercept of the red line is equal to negative 2. So the slopes are the same, the y-intercepts are different, so we have parallel lines. Now let's talk about perpendicular lines. Perpendicular lines are two lines that intersect and form a right angle. Let's go back to our two lines graphed on the coordinate plane. Again, we're going to change the slope of the blue line until it appears that it will be perpendicular to the red line. Remember, that means that they intersect and form a right angle. So they're getting closer and closer to being perpendicular. I'm not sure if you can see it, but the slope of the red line is equal to 2, and the slope of the blue line is equal to negative 0.5. And these two lines are perpendicular. Another way to say that is that the slope of the red line would be 2 over 1, and the slope of the blue line would be negative 1/2, or negative 1 over 2. And that leads us to the condition that must be met for two lines to be perpendicular. Their slopes must be negative reciprocals of one another, and if we multiply the two together, it must equal negative 1. Let's go ahead and state that again. Two lines are perpendicular if the product of the slopes is negative 1, or if the slopes are negative reciprocals of one another. So if both lines are in slope-to-intercept form, m1 times m2 must equal negative 1, or m1 must equal negative 1 over m2. Now these conditions may seem a little more involved than parallel lines, but looking at a numerical example is often helpful. So for example, if the slope of line 1 was equal to 2/3, and it was parallel to line 2, then m2 must be the negative reciprocal, so we flip it over and change the sign. And this would guarantee that those two lines are perpendicular. Notice if we did find the product of these two slopes, we would have negative 6 over positive 6, which is equal to negative 1, as it states here. And let's go and take a look at one more graph. First, we should recognize that these two lines are perpendicular, meaning they form a right angle at their intersection. Let's go ahead and find the slopes of both lines. Looking at the blue line here, let's go ahead and use this point here and this point here to determine the slope. So it looks like we're going to go up 2 and right 4. So that means the slope would be 2/4 or 1/2. Let's do the same for the red line. Let's go ahead and use these 2 points here. Well, now we'll go down 2 and right 1. So the slope of the red line is equal to negative 2 over 1. Now notice in this form it's easy to see that these two are negative reciprocals of one another, meaning if we take this slope here, flip it over and change the sign, it's the slope of the red line, and therefore these two lines are perpendicular. Let's go and take a look at a couple problems where we're given the equation of two lines and we're asked to determine if the lines are parallel, perpendicular, or neither. So the first thing we should notice is that in this first line the slope is equal to 2/3 and the y-intercept is equal to negative 4. Let's go ahead and solve the second equation for y so we can start by comparing the slopes. So if we want to solve this equation for y, we should add 2x to both sides. So we have 3y equals 2x plus 3. Now we'll divide everything by 3. So we have y equals 2/3 x plus 1. Well, the slope of this line is equal to 2/3 as well, and the y-intercept is equal to 1. So notice that the slopes are the same, which means they will be parallel as long as the y-intercepts are different, and the y-intercepts are different. This y-intercept is negative 4, and this y-intercept is positive 1, so the lines are parallel. Let's go ahead and verify this graphically as well by graphing this first line and this second line on the graphing calculator at the same time. So we'll press y equals, and we're going to type in 2/3 x minus 4. So we're going to put the fractional slope in parentheses times x minus 4. That's our first line. Enter. And then for our second line, we'll do the same thing in parentheses 2/3 x plus 1. Now to make sure we all have the standard window, let's go ahead and press zoom 6. There's the first line, there's the second line, and we can see very clearly these two lines are parallel. Let's go and take a look at another one. Same question. Now notice that both of these linear equations are in standard form, so we'll have to solve both equations for y. So to solve this equation for y, we'll start by subtracting 2x on both sides. We have 5y equals negative 2x plus 9. And then we'll divide every term by 5. For this line, we have y equals negative 2/5 x plus 9/5. So the slope is negative 2/5, and the y-intercept is 9/5. Now let's go ahead and solve the second equation for y. So on this one, we'll subtract 10x on both sides. Divide everything by negative 4. And we have y equals 5/2 x. Notice this simplifies. And this would be minus 3. So we have a slope of 5/2, and we have a y-intercept of negative 3. And notice that the slopes are negative reciprocals, therefore these lines are perpendicular to one another. And again, let's go ahead and verify this graphically. So we'll enter in this equation for y1 and this equation for y2 and see if they intersect and form a right angle. Let's clear out the old lines. The first line was y equals negative 2/5 x plus 9/5. And y2 was y equals 5/2 x minus 3. Now if you take a look at these two lines, it looks like they do not intersect in a right angle, and that's because this screen is wider than it is tall, so it's distorted. So what we have to do is square the window. And we can do that by pressing zoom and then option 5 for z-square. And we can now see that these two lines do intersect in a right angle. Okay, that's going to do it for this video. In part 2, we'll take a look at determining the equations of parallel and perpendicular lines based upon given information. I hope you found this video helpful.